Hi YouTube, I'm going to be making an installation video for Arch Linux on a solid state drive. A number of the things in this are going to be specific to my particular setup, which is to have a solid state drive as my persistent storage device, and also that I'm going to be encrypting the majority of the drive so that I have some added security value. I'll also be showing you a few tips and tricks for further securing your data, and also to not leave any residual traces if you're having things on your computer that you don't want there permanently. So, first thing I'm going to do is boot. This video assumes that you've already downloaded the Arch installation ISO and that you have transferred it onto a bootable device. So that's where we're getting started from. Give me a second, I'll make this full screen. There we go. Now another thing I'm going to be doing here is doing everything in real time without any pausing so that you have a better idea of how long this will take you if you undergo a similar process. Now this video is going to try to explain things pretty thoroughly without being so thorough as to become burdensome, so hopefully I get that right. First thing you want to do is run the ls block command to see what all the block devices on your system are, everything that's Linux discovered and that udev has named. Now you'll notice there's quite a few, and not all of that may make sense to you, especially if you have a number of drives connected. So another thing you can do is pass the -S flag for all SCSI devices and then add a lowercase p so that it prints the full device name. So we can see the first result is /dev/sda. Now the two columns you'll be looking for is if the type column says disk, and then over on the far right, if the transport column says SATA, then chances are pretty good that that's the persistent storage device that you want to be installing to. So now we have our device name. Now we need to first partition it so that we can then format and then install onto it. There are a number of utilities you can use to partition a disk. Each of them have their own merits, which you should certainly research and see which one works best for you. I like GNU's parted because I can run all of my commands in a single line. So I'm going to set the alignment to optimal and do it for my SDA device. First thing you need to do is set a label, or also known as a partition table. I choose GPT because it's newer and it has some functions that the legacy MBR does not. One that I like is that you can have as many primary partitions as you like. You no longer need to do extended and logical. So I'm going to create my first partition as boot. The reason for this is that I want to encrypt the majority of my drive, but you cannot encrypt your boot portion of your drive, the boot folder, because if that is encrypted, then Linux cannot load. So boot needs to be on its own partition, separate from the rest of the encrypted device. So first we are creating that. That's going to be a primary partition. I'm going to start it at the beginning of the drive and have it run through the first 257 megabytes. You have a lot of freedom here in terms of what units you want to use and how big you want that to be. I recommend around 200. More is not worse. But if you want to compile your different kernels, if you want to experiment, then it's good to have enough room to mess around in. So I recommend at least 200 megabytes. And then I'm going to name that partition boot. And then the next thing I'm going to do is create the rest of my partition, make part primary, start it where the last one ended off, and run it through the rest of the drive. And then I'm going to name that root. And now those are created for me. So now next is to format them. So there are a number of formatting options. I have come to like BTRFS for stability and security of data. So that's what I'm going to be using for this. I'm going to give it a label of boot and apply that to the partition that I created for that. Next, I want to encrypt my drive. Now you need to encrypt before you can format it with a file system. So I'm going to be using the Xorg Setup program, and I'm going to be using LUX format for it. And I'm going to be applying that to SDA2. It's going to ask me if I'm sure, and when you reply, it does need to be in all caps, otherwise it will fail. Then it asks you to create a passphrase. I'm using an idiotic one just because this is for demonstrative purposes, and I'll be deleting it when I'm done. But you should use, upper lowercase letters, number symbols, and a bunch of them. As long as you can remember it, more there is, the better. So now another note that I want to make. The defaults from the Arch Linux team for Xorg Setup are certainly good enough, but there are other options that you can look into for the cipher that you want to use, for the key size you want to use. That information is available in the Arch Linux wiki and many other places. So, but I found the defaults to be more than sufficient. So now that we have encrypted that device, now we need to open it so that it is available to us. So use the open command on SDA2. Now, SDA2 is the name that UDev gave that device when it discovered it. It's going to need a separate name for the encrypted or decrypted partition. They can't share the same name because they are, in all intents and purposes, separate devices now. So when you tell it to open it, you tell it what device to open, followed by what you want it named once it has been created as an unencrypted device. So I'm going to call mine root. It's going to ask for my passphrase, which I'm now supplying. All right, good. So if I run lsblk again, you will see now that under SDA I have partitions 1 and 2, and then a subpartition under 2, which is now called root. The type is crypt. And so that's how Linux now sees those devices. So now I'm able to format my decrypted partition. Now, in doing a lot of research on the internet, I've found F2FS to benchmark very well on SSDs. There are others, and they all have their merits, and obviously you should do your own research and see what you like the best, but I really like the performance of F2FS, especially in my application. So I'm going to throw the -l for flag for labeling it, and I'm going to label it root, and this has to be applied to the unencrypted partition. Or the decrypted partition. So that's what we're doing now, and it was successful and very fast. So now we can start mounting our devices into the mount folder so that we can start the installation process. So you'll notice that what I had to do was mount, and then the device name was the unencrypted or the decrypted partition, not the actual physical volume. Now next, we need to create a home for our boot directory, because our boot partition is unencrypted and therefore needs to be treated separately. So I just created a boot directory in my mount partition, and now I am going to mount that partition dev/sda1 to the directory that I just created for it. Now from here you can start installing, but that might take a while based on where you are. There's a pretty big Mirrorlist available from Arch, but I don't know how it determines which to download from. So what I like to do is use a program that lets me select the fastest servers for my purpose. So I'm going to change into the directory where that's stored. That's etc/pacmand. And if I list everything in there, there's a folder for GNU PG, but also the Mirrorlist itself. So I'm going to overwrite that with a fresh Mirrorlist that I'm going to download from Arch right now. So I'm going to wget from archlinux.org Mirrorlist, and I'm going to pass it the variable for my country, which is United States. And then I want it to output as Mirrorlist. That will overwrite the existing file. All right. So now if I look at Mirrorlist, you see that I have a fresh Mirrorlist generated as of today, and it is April 14th. Now I only want the fastest one, so I'm going to make a copy of the list that I just downloaded, and I'm going to save it or copy it to a new file called mirrorlist.b. So if I look at mirrorlist.b, then you'll see it has the same information that the other one did. You'll also notice that everything in that file is commented out with those hashtags. Now, everything that's an actual server has only one hashtag. All the rest have two. So all I really need to do is remove one hashtag from the front of each line, and I'll still have the things commented out that I need commented out, but all the servers will be available. So to do that, I will use a stream editor called sed, pass it the I flag to edit in place, and I'm going to ask it to substitute any line that begins, that's what the caret means, with a caret, and replace that caret with nothing. So to explain that again, S means to substitute, and then in between the next two delimiters, which are forward slashes in this case, you tell it what you want it to look for, and then in between the last two forward slashes, you tell it what you want it to replace it with. So this is telling it look for anything that starts with a hashtag and then remove that instant. Actually, I did do something wrong here. I did not tell it what file to apply that to, which should be mirrorlist.b. So now if I look at that file, you'll see all the servers are now uncommented. So now we can use a program called rank mirrors. I'm going to ask for just the 3 fastest that it finds. I'm going to have it use mirrorlist.b, and then I'm going to have it write its output to the original Mirrorlist file. So this usually takes only a minute or two. It's not too long. While we're waiting, I'll say that one of the reasons that I really do like Arch as my favorite, I started with Ubuntu, I moved on to Linux Mint, and now I'm here to stay, I'm pretty sure, with Arch, is that it allows you to build very specifically what you want out of your system. The other advantage is that they've already pre-compiled all those programs for you so that they are very quick to just download and install. But it also gives you the benefit of the Arch user system and the Arch build system so that anything that you do want to configure more deeply, you can configure the source code files and then build them yourself so that you are able to have a very customized system just as you would with BSD ports or with Gentoo. So those are the reasons that I really like Arch. Alright, so it's now run the rank mirrors program, and if I open the mirror list, you'll see that it was generated as of today, and it only has 3 servers available for me, which were the 3 fastest that it found. So I'm going to use the packstrap command to install into mount the base and the base devil groups. So it's going to synchronize with the servers that were just selected, and now it's going to start downloading and installing all of those. If I had passed packstrap the -i flag, then it would have asked me to review it and make sure that that's what I want to do, but I already knew that, so I didn't. Pardon me. So again, I'm not going to be pausing while this is going on, because I want you to be able to see exactly how long this might take on your system with a reasonable internet connection. You can see I'm getting about 1.5 megs per second, sometimes a little faster, sometimes a little slower. The ones that are going to take the longest, if you're getting up from your chair and checking in every once in a while, is going to be, let me see, Linux firmware. See, here's Linux firmware right now. I think Linux actually comes after it, and then the GCC package. So based on which one it's hung up on, you can kind of tell how close you are to being done. GCC is near the end. So once you see that one, then you're pretty close to done. Make init CPIO is something that we are going to have to run because we are using encryption. Make init CPIO is what loads before the rest of the operating system loads, and it has what it calls hooks, which are things that it needs to look for and or execute before it hands the rest of the process off to the operating system itself. By default, make init CPIO is not going to look for encrypted devices, so we're going to need to tell it to look for Linux devices once we get started here. And I'll show you how to do that once we finally get there. It should probably be another 2 or 3 minutes, I'm betting. So if you want, go ahead and hover over the play bar on YouTube until you see the screen looking differently, and so that you can skip this process. Okay, now it's on GCC, which means that we're pretty close to done now. It's only going to be a few more packages after that, and then we will be ready to move on to the next thing. And again, I'm using an SSD, so if you see this process being significantly faster for me than it is for you, that's probably why. Hard disk drives are going to take a lot longer, based on my experience. Also, even if you're using an SSD, it still might be going a little slower than mine, just because I'm using the 850 Pro from Samsung. And I did that based on research of what had the quickest times that was still affordable to me, and that's the one I like the best. So, you know, read and write times will still vary between different SSDs. All right, looks like we're just about done. And we're done. So the next thing that we need to do is generate our file system table. That is done by using the gen fstab command. Arch recommends that you use the minus lowercase p flag to ignore pseudo file systems, and then you can tell it whether to use UUIDs or label when creating the file system table file. I prefer UUIDs because it is persistent across reboots, because if you use the label might change based on what udev decides to call it the next time you power up. So anyways, you can just overwrite that or append it to the fstab file in the mount directory under etc. Now that we're done with that, we can root or change root into our new environment. So up until now, all of the commands that we've been running have been run from the Arch ISO, and now we're going to change root into the environment that we just installed into our hard drive. So to do that, we just tell it from what directory we want to be working from, and then the script for this also allows us to specify what shell we want to use once we're in. So I prefer bash, so I asked for bash. I think it'll let you use regular shell, but also ZSH, I believe, is available. Not sure. Anyways, what we do now is we localize our machine. So what you can do is just use nano to look into etc locale.gen, and then you just look through the entire list for the ones that apply to you, uncomment them. Since I already know what locale is good for me, and it is a pretty intuitive system to be able to remember, I just echo out what I'm going to be using. So it's en_us.utf8, and then utf8 again to set the standard, and I echo that out to locale.gen. Then once I run locale.gen, that's the only entry in the file, and it's good to go. A couple other places we need to set that localization information is to a locale.conf file. So we're going to echo that our language is equal to what we just set it at. And we're going to echo that out to etc/locale.conf. And then the last thing we need to do is export it as a language variable. So export lang equal to whatever one is correct for you. Now that we've done that, we want to get our time correct, our local time. So if I run the date command, it'll say that it's 3:30 tomorrow morning, which it's not for me. That is Greenwich time, I believe it is. So to set your own time, you need to see what time zones are available. So you can go into the user/share/zone info directory and take a look at what countries and continents are available. I'm in America, so I'm going to look at that one. I'll pipe it through less so that you can see all that's available, which is quite a lot. When it says America, it doesn't mean necessarily United States. It means the Americas. I'm in Central Time, which I know Chicago is also in, so I'm just going to use that. So you need to create a symbolic link from the time zone that you found that applies to you and set it in the local or the etc directory as local time. So now if you run date again, you should see that the time and date are correct for you. Now that it is correct, go ahead and run the hardware clock command to set your clock to the local clock and to the UTC time standard. Now next we want to name our device or our machine. So I'm going to call it ArchVM because I am in a virtual machine. I'm going to echo that out to etc/hostname. You also need to put that into the etc/hosts file, and it'll be right after this localhost entry on both lines. Whoops. So now that's done. You can save. Another thing is that you'll obviously want a network connection when you boot in. So in order to activate those, you need to know what udev has called those devices. Or maybe it's systemd in this case. I can't remember. Sorry, I'm not actually that knowledgeable. But you can run ip-link to look up what those names are. So I only have one entry because I'm using a virtual machine. If it's an Ethernet port, it's going to start with an E. If it's a wireless device, it's going to start with a W. So I'm going to show you by doing it how to enable automatic internet for an Ethernet device, and then I will show you also how to do it for a wireless device. So you use the system control command to enable DHCP-CD, it's called, which is the DHCP daemon, and you're going to run it at the device as it's called when you run IP-link as a service. So that will create the symbolic link that is necessary so that when you reboot, when ENP or whatever your device is called becomes available, it will run DHCP as a daemon on that device. Now, if you have a wireless device, it's going to be a little different. There are a lot of different ways to do this. This is just the way that I've found the easiest. So that'll be system control, enable, net control -auto at WLP or whatever yours is called, blah, 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 dot service. And what that will do is make your wireless device aware that it needs to connect to whatever profile or to whatever device that it recognizes automatically. And so if you carry your laptop between home and work, once you get home, it'll remember your home device and connect to it. Once you get to work, it'll remember your work device and automatically connect to that. So that is a handy thing that I enjoy. All right. So also, I guess I should say that if you are going to use wireless, you'll need to install some wireless tools. Dialog is one. Let me see. WPA supplicant and WPA Action D. So you'll want to make sure all of those are installed if you're going to be using what's called Wi-Fi menu once you boot into your new working system. Pardon me. Okay. So moving on, we've now configured our network devices so that they will be available to us once we get going. Some other good things to do: set a password. If you don't give it any arguments, then it just assumes you're setting the password for the user you're currently logged in as. So in this case, that's root. So set a password for root. You can also use this time to add users. So that's a user add command. -m tells it that you want to create a home directory for that user. -g tells it what group you want it to belong to. -s will tell it which shell you want to be the default for that user. And then the last thing you put in is the name that you want the user to have. And then you give it a password by invoking the password command again, but specifying this time, whoops, let me try that again. Sorry. By specifying which user you want it to be for. And now we've created a profile for a new user. Now, there are many things which says that you don't want to run as root by default if you're just going to be a regular user of your PC. So now that we've created that, we want to be able to give them super user privileges for the ability to, update the system, install new software, remove unwanted software, those kinds of things. So in order to do that, we need to add that user as an entry to what's called the sudoers file. That's located in etc under sudoers. And you'll scroll for a little while. I think it's about halfway down. I don't really know because I don't have a scroll on the right, but you just type in the name of the user under user privilege specification and then just mimic the permissions that are already given to root above it. And then that will make sure that the user you created now has super user privileges. Okay, so you might remember that I said I created a GPT partition table at the beginning. There was something I forgot to mention, I think, which is that the choice that you make there will affect what bootloader you install, whether or not you can install it, and if so, how it needs to be configured when installing. So I prefer to use syslinux instead of grub, just because it's lightning fast, it's super easy to configure and use, so that's what I'll be using in this case. I don't think that's as recommended, or it may not even be recommended at all if you're going to have multiple operating systems on your computer. I only use Arch Linux, so I have no problems. So, like I said, I'll just be showing you how I do things. Obviously, if you want to install grub, then you want to start to diverge from the process right about here. So in order to use syslinux on a GPT partitioned disk, however, you need to use the GPT-fdisk, or it needs to use the GPT-fdisk program. So install that along with syslinux. So now that you've installed syslinux still needs to be able to install itself into your boot partition. You're going to use the syslinux-install_update and then pass it the IAM parameters, which just gives it information to, look for the correct thing and install it in the right part of the drive. Now, there's going to be something that we need to configure. Once that's installed, it's going to be in your boot directory under the syslinux folder, and it's going to be called syslinux.cfg. Since I don't have anything else that I need to install, I like to delete everything except what I'm absolutely going to use. So you need to keep a default in there, and you need to keep a label in there that matches what the default is. I don't use a menu, I just want it to boot right away. So, deleting everything else, the parameters under a label need to be where to find the Linux kernel itself, which is this line, and then also where to find the initial RAM environment, which is right here. Line 2, however, just has a default entry which is not correct by itself. I mean, it may be correct for your system, but definitely check it, definitely revise it. The first thing it's going to look for is where is your root device. Well, ours is not actually on a physical partition. It's actually on the mapped partition, which we call root. So remember that if you're using encryption. In addition to that, you need to tell it that it needs to look for a cryptdevice and what physical partition that's on and what it's been called after that. So the things that we are appending to the kernel line is first look for a cryptdevice on physical partition SDA2 named root so that the root file system is available on that unencrypted partition under mapper. So now that file is good to go. It won't load any visible menus. It'll just flash on the screen for just a moment and then load the rest. Now, another thing that's important that I brought up a little while ago is that we're going to be using make init cpio to create kind of a pre-operating system environment where it runs a number of things that it knows to look for and execute before the actual operating system executes. So we need to edit that configuration file, which is called make init cpio.conf in the entity directory. We're going to browse past modules, browse past binaries, browse past files. None of those are necessary in this setup. And then once we're at the hooks section, we need to add the hook for encryption, which is encrypt. So that's letting make init cpio know that when it's running, after it's found all block devices, it needs to look for one that's encrypted before it can start loading file system information. The last thing it does is a file system check. Now, as it stands, it's not going to be able to run a file system check on f2fs because we've not yet installed the utilities for it to do so. So this is a good time to install f2fs tools, and if you would like them, the btrfs programs for your boot partition. So now that those are installed, you want to run the make init cpio program so that it will generate a new init ramfs, and you're telling it to use the Linux preset. That's what the -p means. So now that we're generating that, you can see it running all the build hooks. If we had not installed f2fs, then it would have given an error that no file system check information was available for f2fs. All right. So what we've done now is we've installed a base system, which would give us a command line, and we have added a root user, a user who can run sudo, and we've installed a bootloader so that it will boot, and we've encrypted the majority of our drive so that it is relatively impervious to casual attackers. So what we're going to do now is exit our rooted environment and power off the device for right now. You can reboot if you're on a physical device. However, since I'm in a virtual machine, there's a bug where, actually I haven't checked in a while, it may no longer be there. But at the time I last used it, if the Arch ISO is still attached, if it boots into the ISO and you tell it to boot from the hard drive instead, then it will just freeze up and not work. All right, so the first thing that's happening is that it is running the hook, or the first thing that we are prompted for is that the build hook encrypt. Notice that there is an encrypted device and it's asking us for the passphrase to decrypt it. So the sign, or the fact that it gave us that, is a sign that things are going well so far. Okay, so now it's asking me for a login. I can log in as my new user, or I can log in as root. Root gets around a couple of things that can be annoying when you're still installing a lot of packages, so I'm just going to stay in here for now. So obviously, as you can see, all this gets you so far is just a command line, and probably you want to see more things than that. So one thing that I will do is I will open up the file system table, and what I'm going to do is create a folder in my user's home directory that I'm going to mount directly into RAM. And what that means is that instead of existing on the hard drive, it's going to exist only in temporary storage in the random access memory, which means that it will not be preserved across reboots. Now, that is the standing definition of a temporary save space. So only put things in there that you don't need. But the other advantage is that there will literally be no record of it ever being there. I don't know how many of you know about deleting files, but when you delete a file, it is not actually being deleted. The operating system is just being informed that that portion of the disk is now available to be written to again if it needs the space. So it may never be written to. There are commands like shred in Unix utilities, which look for where it knows the file to be and then overwrites it, but that's not effective in journaling systems where there may be several copies. And also with the new microcontrollers in SATA technology, which also has its own information with where leveling algorithms and all that on where the file actually is. So if there are going to be files that you are worried about permanently getting rid of, it is better to just work on them in a temporary workspace so that they were never on your hard drive in the first place. Anyways, in order to do that, you set what it is first, where it's going to be located. And in this case, I'm just going to call it temp. Next, the file system type. And then the mount options that you want. So I leave it wide open, because I don't see any harm in that. You can correct me if you know that I'm wrong. And the no A time flag, so that there are no access time writes to it, because those aren't necessary. And then pass and dump can both be 0. So again, this will allow you to use the temp directory in that user's home folder to write temporary files to that will not be preserved across reboots. You can use an rsync script or something to preserve it if you are also going to mount like a Firefox profile or something for a quicker performance. I'm not going to go over that in this video, but it is definitely possible. The reason that I like this is because then nothing that is private or that I want to keep secure is never kept on my hard drive. Even though it's encrypted, I just like the security, and the point of this video is to show you different security options that you can have, because you don't have to sacrifice too much speed when you're using an SSD. All right, so we want to have some kind of visual environment, or most people do anyway. So, oh no, we use pacman now, -s for synchronized packages. And Xorg is going to be your video server. That's going to be what you need in order to install a desktop environment like Cinnamon or a window manager like i3. So that'll be the first thing that you want to install. Now, when that's installed by itself, it doesn't give you much in the visual sense, certainly not anything that you may be used to. So you want to do your research and determine what kind of desktop environment you want or window manager that you want. I use i3, and I'm going to be using that in this video, not only because it's what I'm most used to and like the best, but also because it's going to be the quickest download time out of everything that I could show you. So I'm going to be downloading the i3 window manager. Now, another thing that needs to be downloaded is the Xorg-xinitr. Nope, that'll be the file name. Xorg-zinit is what you're going to need in order to inform the Xorg server what you want it to launch once it's invoked. Okay, because you can have GNOME installed and Cinnamon installed and Mate installed and KDE and all those others, but there will also need to be information passed to Xorg about which one you want to load. All right, and that can be done through a number of ways. GNOME has its own manager, Slim is a manager, things like that. I just like to sign in from the command line and have it launch it simply from there. So that's what I'm going to be using for that. Now, the Xorg group will download and install all packages that it has for Xorg, whether it's applicable to your hardware or not. If you know which packages are specific to your hardware, then it's best probably just to install only those so that you don't have leftover packages bloating. But I think there's 70 or 75 available in the Xorg package. They don't take too long to download those, so as you can see, we're pretty much already done. There we go. Now, a couple other things that are important to install is a menu system if you're going to be using i3 so that you can access programs. Pardon me. And then also you want a terminal. So a favorite of mine is rxvt-unicode. Okay, so those are installed. I'm going to exit out of root and sign in as my new user. All right, so a last couple of things to do is tell X what you want it to launch when you are signing in as user. So I'm going to I need to echo exec i3. This works with or without quotation marks in this particular instance, to a file name xinet rc. And that is the file that Xorg will look at when you invoke it. And then we automatically invoke it when we log in by echoing the startx command and appending it to our bash rc file. Now note that this will only work if bash or something very similar to it like ZSH is being invoked. If you're using fish or another one, then this will not work, but this is what I'm using. So now if I run startx, it will automatically run that for me, and the i3 wizard will notice that I haven't run this before. Would it like me to generate a file for me? Yes, please. It'll ask, do you want to use the window or the alt key as your default? So I'll ask for alt in this instance. And so, let me see here. Your mod key, Shift E, will allow you to exit out of things. All right, and so those are the basics. You would need to make your temp directory also so that it is listed there, and then when you reboot, it will be mounted as a temporary directory. Not only is that good for security reasons, like I said, but it also is a really handy build space if you're going to be downloading things from the Arch user repository. So another thing that I like to do, since Google Chrome's browser allows you to synchronize all your history and settings and all of that, is I will mount my Google Chrome session into temporary directory every time I use it, so that I just have to sign into Chrome and I have all of my data, but then when I reboot, none of it was there on my hard drive in the first place, so none of it can be recovered. It's all very fast, very secure. So that's my video. Hopefully it was informative. If you have any questions, please leave them in the comments and I will try to answer them as best I can. Thanks for watching.